Okay, let's start. Today I need to do few more statistic questions, part A related questions, then we can complete the session. Take your tutorial 2020, start 2020. Start 2020 question. Okay, let's start. 2020 LL question. A set of 5 observations of positive integers, say x1, x2, x3, x4, x5, positive integers less than or equal to 10. Less than or equal to 10. Has mean, median, mode equals 6. Mean, median, mode all are equal to 6. Then definitely at least 2 will be 6. At least 2 will be 6. And median, let's consider here ascending order. Then because of this you can say median equals 6. Therefore x3 equals 6. Therefore you can consider here x1 6 6 x4 x5 combination, or here this can be happen. Then x1 x2 6 6 x5 combination. These two combination possible because we have two modes. We have mode 6. Okay, we have mode 6. Therefore here ascending order I have written here ascending order. Therefore mid value we know 6. Then there will be another 6 value that can be right hand side or that can be left hand side. Okay. Then thereafter mean 6. X bar equals 6. 6 equal x1 plus 6 times 2 plus x4 plus x5. Divide by 5. Okay, 1, 2, 3, 4, 5. 30, x1, 12, x4, x5. Then here 18, x1 plus x4 plus x5 equal 18. 18. Okay. Now we need to guess values. Further given the range of observation 9. Range equal 9, that is x5 minus x1. x5 minus x1, 9. Okay. Now we have two formulas, but we have 3 unknowns. We can't take by solving the equations. Then you guess values here. Let x1 equal 1. Let x1 equal 1. Then x5 equal 10. x5 equal 10. Then corresponding x4 value, find x1 1, x5 10 11, x4 equals 7. x4 equals 7. Then let x1 equal 2. x1 equal 2. Here 2, x5 equal 11. Now it is completely wrong. That cannot happen. You forget it. So when you consider all the others, that will be wrong. Because values less than or equal to 10, this is very important relation. Therefore, only possible value 1, x1 1, x5 10, x4 7. Therefore, possible answer data set 1, then x2 value 6, 6, then x4 value 7, x5 value 10. x5 value 10. Here data collection 1 6 7 1 6 6 7 10 is the collection. So first you write ascending order according to given relation. You try to write equations but solving those equations we can't find possible values, but we have to guess them. You have to guess them. Huh? Okay, that is 2020. Then try 2019 A-level question. 2019 part A question only. Part A question. (2019). Start it. (2019) 5 positive integers, each of which is less than 5, have 2 modes, one of which is 3. Then one mode given 3 and given there are 2 modes. No? 5 possible values. 5 values given. Then x1, x2, x3, x4, x5. Here these are positive integers. Less than 5, no? Less than 5. Have 2 modes. Here have 2 modes. Then AA, then with one of them 3, no? Then when you consider 3 modes, no? Their mean and median both equal to 3. Mode, 1 mode, 3. 2 modes. And mean, median 3. Then let's start from here. Median 3, no? Then mid value 3. 3. Then there are another 4 values to be determined. So when you consider mod, here mod 3, no? Then definitely there will be 2 3 values. So when you consider 3, then that can be in right side, or here it look like this, or here 1 3 3. These two possible. So if we write this way, then initial value AA 3 3, here B, here P 3 3, Q Q. We have 2 modes now. We have 2 modes. Then we have 2 possibilities. Then mean given again 3. Then consider this case 2A plus 6 plus B divided by 5 equal 3. Then 2A plus B 9. 2A plus B equal 9. Now you try to guess value. Now consider A equal 1, A equal 1, B equal 7. B equal 7, no? A equal 1, B equal 7. Then value less than 5, then this is wrong. Then let A equal 2. A equal to 4, 5, B equal 5. Less than 5, then this is wrong, no? It is equal to 5 now, all values less than 5. Then let A equal 3, B value. A equal 3, 6, B value 3. B value 3. B value 3. 2 modes 3 3, B A. 2A 6, B. A equal 1, B equal 7, A equal 2, B equal 5. Equal 3, B equal 3, it is wrong again because 2 modes, no? Then let A equal 4, A equal 4, then B equal 8, B equal 1. It is correct, no? Correct. Therefore, possible values 1, 4, 4, 1, 4, 4, 3, 3. Here 1, 3, 3, 4, 4. Here the set. That's the set. 1, 3, 3 and 4, 4 is the set. That is 2019. Then go to 2018. Go to 2018. (2018). (2018), 5 positive integers, each of which less than 8. Then here A, B, C, D, E, positive integers less than 8. Their mean is to mod is to median 6 to 10 to 5. 6 to 10 to 5. Okay. Here it is. Median mean mid value. Then mod, when you compare median and mod, here mod divided by median equal 10 divided by 5. Then here mod equal twice of median. Mod equal twice of median. So you consider here A, B, C, D, E, no? Then let's say median is C. Here this is median. Then mod twice of that. Then definitely these two will be mods. Then here say D and D. That is twice of C. 2C, 2C, no? Then here mod twice of the median. So A, B, C, D I have taken initially ascending order. Therefore, when you consider ascending order, ratio of 6 to 10 to 5, when you consider these two, then mod divided by median 10 is to 5, then mod equal 2 times median. Then when you consider this is the median, then these two will be mod because that is larger than median. Therefore, 10 is to 5, then 2C to 2C, then C, 2C, 2C. Now here the data set now. Now further, when you consider mod and median, mean, okay, now mean x bar value A plus B plus C plus 2C plus 2C divided by here 1, 2, 3, 4, 5. This is median now, mean value. Now mean divided by mod or mean divided by median, you can take whatever. Then x bar divided by, I'll take mod, sorry, median. Then x bar mean A plus B plus C, 5C. Here 2, 5, 5C over 5. Then x bar 6, median 5, 5. Then here A plus B plus 5C equals 6. A plus B plus 5C equals 6. Then further you consider here A plus B plus 5C equals 6. Okay, go up to that. Then all values less than 8, ne? Then you have to guess the values. Then definitely here A, B, C, they are different. A, B, C different, no? Now let A equal 1, B equal 2. A equal 1, B equal 2, then 3, then find C value. Then C value a equal 1, b equal 2, then here 3 over 2. It is wrong. Then a value 1, b value 3, 4 5 over 2, c value 5 over 2. It is wrong. Then take a value 4, 5c, 5c, then here 6c. Now it is okay. Then a plus b equal c. A plus b equal c. Now consider, let a equal 1, b equal 2, then c equal 3. This is possible, no? Then let a equal 2, b equal 3, c equal 5. C equal 5, then 2c value 10. That exceed 8, no? Then this is wrong. Then only possible value a, b, c 1, 2, 3. Then a value 1, b value 2, c value 3, and 6 and 6. Here the value. Here 5c. Yeah? Here 5c. Then 1, 2, 3, 6, 6. Now then come to 2017 part A question. 2017 part A question. Start it now. 2017 part A question. Start it. 2017. The values of 6 observations A, B, B, X and Y, where A, B, X are distinct positive integers, A less than B. And here A, B, B, X and Y. Then A less than B. So here they are integers, positive integers. What are the modes of 6 observations? Then modes A and B. Here we have 2 modes. We have 2 modes, A and B. It is given that sum and the product of these modes are X and Y. Then A plus B equal X, AB equal Y. Sum and product of these 2 modes X and Y. If the means of 6 observations 7 over 2, mean x bar 7 over 2. Find the values of AB. So now we write mean formula. Then here 2A plus 2B plus x plus y over 5, 6. Here it is. Then 21, 2A plus B, x plus y. Then A plus B equal x. Here 21, 2x plus y. Then here 3x plus y equal 21. First formula. Now you have to guess values now. Then means of 6 observations 7 over 2, no? Then 7 over 2 mean that is 3.5. Then these values are very small integer values. Then start from 1. Then let A equal 1. Let A equal 1, B equal 2. A equal 1, B equal 2. Then x equal 3, y equal 1 into 2, 2. 1 into 2. Let's write. Then A, B distinct, no? A, B, X, Y distinct. A, B, X, Y distinct. Now here, these two coincident, therefore it is wrong. It is wrong. Then A equal 1, B equal 3. A equal 1, B equal 3. Then x equal 4. A plus B. Then AB equal 3. Then y equal 3. That also wrong. Then A 1, B 4. X equal 5. A1 x equals 5. Then y equal AB equal 4. That is possible. That is possible. Now B, Y here coincident. A, B, Xi distinct positive numbers. Again wrong. Then A2, B3. Then x equals 5, y equal 6. Y equals 6, AB equals 6. That is possible. Now that must satisfy this one again. 5, 6. Then that satisfied 3x plus y equal 21. Then this is the correct one. Therefore 2, 2, 3, 3, 5 and 6. 2, 2, 3, 3, 5 and 6. Na? Okay, better to select xy. Better to select xy. X equal 1, take y value. X equal 2, take y value. Like as you better to select from here. But here this is correct. Huh? Anyway, this is correct. That's 2017. So by solving the equation, we can't identify the values. We can't completely solve the equation. You have to check. You have to guess the values. Okay, then try 2016. 2016. Start. (2016) the mean of 3 distinct integers less than 11 is 7. Then consider x1, x2, x3, 3 distinct integers. They are not positive but integers. Then less than 11. Mean 7. Then x1 plus x2 plus x3 over 3 equals 7. Then x1 plus x2 plus x3 equal 21. Here first formula. So all are distinct. Here distinct. Now you take another 3, x1, x2, x3, x4, x5. So now again 2 integers are taken. The mean of all 5 integers 5 now. Mean of all 5 integers 5. Therefore x1, x2, x3 plus x4 plus x5 divided by 5 equal 5. 5. The only mode of these 5 integers is 3. Only mode. So here these are distinct now. These are distinct. So after adding another 2, here these are distinct mean no mode. So then x4 or x5 can be 3 or one value here, here one value 3 here and another value 3 here, can be 3 another one here. Okay. Now here the possibilities mod equal 3 now, then x1, x2, let's say AB, say x1, x2, then here 3, 3 x5 or this is possible, or x1 x2 3 possible. These three possible. x2 x1 x2 3 x5 mode is 3 no. There is only one mode. Only one mode means actually it is at 2 equal values no. So at least 2. Then there can be 2 equal 3 values, or there can be 3 equal 3 values. Then we have two possibilities. Now you have to check further. Now here this case x1 x2, you consider this one, then you take here x1 x2 3 plus x5 divide by 5 equal 5. Then by this 25, 6 x1 plus x2 plus x5. x1 plus x2 plus x5 equal 25 minus 6, 19. Then one of this value again 3. Then by 1 here second equation. By 1, so we know one value is 3 no. Then x1 plus x2 equal, take one value 3, 19. Sorry, 18 no. Here 1 no. Then 21 minus 1. Then x1 plus x2 18. Then one value 1. Then x5 equal 1. x5 equal 1. Okay, then select the other two. Value less than 11, value less than 11. Then here 11, 7 possible. Then x1, 7, x2, 11 possible. Now 10, 8, no? 8, 10 possible. 8, 10 possible. Less than 8, no? Then no any other values, no? No any other values. Then 1, 8, 10. 1, 8, 10, 3. 1, 8, 10, 3. That's the value. Then 2015. Continue up to 2011 part take actions. Continue. A set of 7 whole numbers is arranged ascending order S 1, 2, 4, x, y, 11, 13. Y is mean of the numbers. Mean 1 plus 2 plus 4 plus x plus y plus 11 plus 13 over 7 equal y. Then 6, 7, 20, 31. X plus y equals 7y. Then 6y minus x equal 31, first equation. Set of 7 whole numbers arranged ascending order as follows. Y is the mean value. Okay. Now you have to guess values. So ascending order, then x value greater than 5. X value, x and y values 5 to 11. No? Let x equal 5, then corresponding y value. Here 36, y equals 6. Possible. Let x equal 7, y equal 38 over 6. All numbers no wrong. Then x equals 8, y equal 39 over 6. Wrong. Then here correct. X equal 9, y equal 40 over 6. 40 over 6. It is wrong. X equal 10, y equal 41 over 6. It is wrong because they are whole numbers. Na? Then this is only possible value. X equals 5, y equals 6. X equals 5, y equals 6. Then x equals 5, y equals 6 is the possible solution. Now they have to show that variance of the numbers 120 over 7, variance. So you take variance formula. So we have direct formula for variance. Then that is variance sigma xi square divided by n minus x by square. Then 1 square, 2 square, 3, 4 square. Then x value 5, y value 6, 11 square, 13 square, 7 over 7. Mean y, no? Y value 6. Y value 6. 6 square. Okay. Then you simplify this. You have 1, 4, 16, 25, 36, 121, 169, 7 minus 36. Then here this will be 120 divided by 7. 120 divided by 7. So 2011 to 2019, there are two statistic questions. We have missed few questions. Then let's do them again. Then you do 2015 second question. 2015 second question, and then we can complete the remaining part. Do 2015 to 2019 second statistic question, part A second question. So we have done only one. 2015 to 2019. 18. Okay, 2015 second question. So here a data set given, number 1, 2, 3, 4, 5, 6. Frequency alpha 9, gamma 11, 8 and 7. 50 times, then here total 50. Given that mean of the distribution 3.66. 3.66 mean. Okay, 3.66. Then 50 equal, mean equal 1 times x bar, 3.66 equal 1 times alpha, 2 times 9, 3 times gamma, 4 times 11, 5 times 8, 6 times 7 over total we know 50. then 36.6 times 5 alpha 18, 3 gamma 44, 42, then alpha plus 3 gamma 36.6 into 5 183, 183 minus 18 minus 126, then alpha plus 3 gamma equal 183 minus 126, 18, 144, 183, 144, 9, 39, 39. Then full frequency alpha plus 9 plus gamma plus 11 plus 8 plus 7, 50. Then alpha plus gamma equal here 20, 28, 35, 15. Here second formula. Now we have two simultaneous equations, find alpha and gamma. Then 1 minus 2, 2 gamma, 39 minus 15, 24, gamma equal 12, then alpha equal 13. Gamma equal 12, alpha equal 13. So by that calculation you can find alpha, beta, gamma. Then mode of the distribution, mode, highest frequency element, now alpha 13, gamma 12, then highest frequency element 1, mode 1. Then median, mid value, then 25th element, here 15, 25th, then 13, 9, 22, 22, here this will be median class, then this will be median, median is 3, median is 3. Gamma equal 12, alpha equal 3, ne? Alpha equal 3, yeah? Gamma equal 12, alpha equal 3, not 13, it is 3. Then the mode equal 3, mode equal 3, median mid value here 9, 12, 24, 24, here 4, median 4, median 4. Alpha equal 3, then highest frequency element is 3, therefore mode is 3, mode is 3. Then here 15, 25th element, then up to now here 3, 9, 12, 12, 12, 24, then 25th element goes to here. Therefore, this will be mode, median, median, and here this will be mode. That's 2015 question. Then go to 2016 second question. 2016 second question. Second question. Start. Okay, here a table given, number, frequency, one, two, three, four, 5. 1 P Q 5 2. If the mean and the variance, here mean x bar given 3 and variance given 6 or 5. Find the values of P and Q. Find the values of P and Q. Here, when you are finding mean, here multiply these two. X bar mean sigma fi xi divided by sigma fi. Then 3 equals sigma fi xi. Here this is xi, here this is fi. Fi. Then 1 into 1, 2 into P, 3 into Q, 4 into 5, 5 into 2. Divide by frequency sum. 1 plus P plus Q plus 5 plus 2. Now just simplify. 3 into 5, 7, 8. 8 plus P plus Q. Here 1, 2P, 3Q, 20, 10. Okay. Then simplify. 3P, 2P, P, 3Q, 3Q, Q value 0. Then here 24, 4, 6, 7. P equals 7. Okay. Then 3Q, 3Q cancelled. 3P, 2P, P. 24. Here 20 minus 4 plus 6 plus 7. P value 7. P value 7. Then variance S square sigma fi xi square divided by sigma fi minus x bar square. Now variance given 6 over 5. Then sigma fi xi square. Then 1 times 1. Xi square 4 times P. 9 times Q. 16 times 5. 25 times 2. Frequency sum sigma fi. Then 1 plus P plus Q plus 5 plus 2 minus x bar square. X bar given 3. 3 square. Okay. Here our formula. S square equals sigma fi xi square divided by sigma fi minus x bar square. Okay. Now we have P value. Further simplify. Then 6 over 5. 1 plus 4P, 28. 9Q, 80. 50. Here 8. 1 plus P, 8. 8, 10, 15. 15 plus Q minus 9. Okay, further you simplify. Multiply by 5 and 15 plus Q. 5 into 80, 108, 158, 159. 9Q. 9, 15 plus Q. 15 plus Q into 5. Then obtain Q. $90 plus 6Q, 159 times 5. 795, 45 cube, 45 into 15 675 45 cube, then 6 cube 795 765 75 120 30, then q equal to 5, q equal 5. Find the values of p and q. Consider general formula and find unknowns, that's it. Then go to 2018 second question. Second question. Temperature in certain city was recorded daily for 20 days. For this set data, mean mu and standard deviation were calculated 28 and 4. Then 20 days. Mu mean 28, standard deviation 4. However, after detecting that 2 of the above temperature have been mistakenly entered. Now 18 correct, 2 wrong. 18 correct, 2 wrong. Therefore, you consider x1, x2, x3, x18, these are correct. Then mistakes here, 35 and 25, they were later corrected 25 and 31. Then here this includes 35 and 21. Then we have to reset this one, 25 and 31. 25 and 31, we have to recorrect. Okay. Now mean 28 equal sigma I equal 1 to 18 xi. These are correct with 35 31, 35 21 over 20. Here general calculation. Five, 6, 0, sigma xi I equal 1 to 18, here 56, then sigma I equal 1 to 18 xi value 560 minus 56, then 504, here correct values. Now you have to calculate new mean, corrected mean, sigma I equal 1 to 18 xi values, then here correct value 25 and 31. 25, 31 over 20 now. Okay. 18 values are correct, 2 values are wrong. Then for wrong thing we have calculated value. Then you have to remove that wrong values, finally add correct values. Now we have added here correct values. Then 504, 56 over 20. Then that mean won't change. Mean value won't change. Mean value same. Here 25, 31. Here 35, 21. Here 56. Here 56. Then no mean change, but variance will be changed. Therefore, here variance, again go to formula. S square equals sigma I equal 1 to 18 xi squared plus 35 square 21 square divided by 20 minus its mean 28. So that very standard deviation 4 square. Then sigma I equal 1 to 18 xi square 4 square plus 28 squared into 20 minus 35 square minus 21 square. Then new standard deviation, new variance, a corrected variance, sigma I equal 1 to 18 xi square. Now correct value 25 and 31. 25 square, 31 square divided by 20. Now new mean again 28. 28 square. Okay. Then we know this value. You put that one here and do simplification. Then sigma equal 1 to 18, 4 square, 28 square, 20 minus 35 square minus 21 square plus 25 square, 31 square over 20 minus 28 square. Now simplify. Then here 4 square into 20. Here 4 square 20 cancel, 4 square. Here 35 25 minus 35 square minus 25 square. 31 square minus 21 square over 20. Now further we can simplify. No? Further you can simplify and get the value. (16) here 10 times 760 plus 10 times 52 over 20. Now simplify. Therefore, standard deviation square root 12. Standard deviation is square root 12. Okay, then go to 2017 second question. 2017 second question. 2017. The mean and variance of 10 numbers x1, x2, x3, x9, x10. Mean 10, variance 9. It is given that the mean of the 9 numbers which remain after omitting number x10 also 10. Then x1 plus x2 plus x3 x9 x10 over 10 equal 10. Then further x1 plus x2 plus x3 plus x9 over 9 again given 10. 9. Therefore here by this x1 plus x2 plus x3 x9 x10 equal 100. Here by this x1 plus x2 plus x3 plus x9 equal 90. Therefore take here 1, take here 2, 1 minus 2, x10 equal 10. Then here the value that we remove. Find the variance of these 9 numbers. Find the variance of these 9 numbers. Now, new variance sigma I equal 1 to 9 xi square plus, here before that, here x1 square, x2 square, x9 square, x10 is 10 now. 10 square divided by 10 minus, here mean x bar 10. 10 square, here this variance 9. 9. Variance is 9. Then you find this value. x1 square, x2 square up to x9 square sum. Here 109, 190 minus 100, 990. Okay, now here 109 minus 100. 109 times 10, 109 times 10, 1090 minus 100, 990. Is the value. Now by that you can find new variance. Now write new variance. Then new variance x1 square, x2 square up to x9 square divided by 9 minus x bar square. Now here this one 990 divided by 9, new mean won't change, that is 10 again. New variance 10. New variance 10. Always remember mean, variance, standard deviation, those formulas are very important. Then go to 2014, we have 2 part-take questions. 2014, 2 part-take questions. (2014). Take time to start. (2014), the mean and the median of 5 observations, say x1, x2, x3, x4, x5. Median 7, mean x bar 7, median 9. The only mode of the observation is 11. Mode 11. There's only one mode. So median mid value, then because of this, you can say x3 is median. x3 is median, mid value is 9. Then only one mode 11. Therefore, these two will be 11. Therefore, now 9, 11, 11, x1, x2. Find largest observation and the smallest observation. Okay. Now, write mean x1 plus x2 plus 9 plus 11 plus 11 of 5 equal 7. Then x1 plus x2 equal 35 minus 20, 31, 4. x1 plus x2 equal 4. x1 plus x2 equal 4. Assuming that all observations are positive integers. They all are positive integers. Positive integers. Therefore, we take here 1, 3, 4. So, you take x1 1, x2 3, then that is true. Then x1 2, x2 2. This is wrong because there is only one mod 11 and this is wrong. Then we have possible values here 1, 3, 9, 11, 11. 1, 3, 9, 11, 11. 2014 first part. Then go to second question, 2014 second question. 2014 second question. So here a table given. Five to 15, here class intervals 15, 25, 25, 35, 35, 45, 45, 55. Here frequencies 16. Before that, find xi mid value 10, 20, 30, 40, 50. 16 x 30 y 20. Then frequency sum 100 observations. Then 100 equal 16 plus x plus 30 plus y plus 20. Here 50, 50, 40, 36, 34. 50, 50, 40, 34. Then fi, xi, no need to calculate yi because these are small values, no? And other than that, we have two unknowns. Therefore, no worries, just write usual pattern. 160, 20x, 900, 40y, 1000. Then calculate here 1900, 2060 plus 20x plus 40y. Now here given mean of the distribution 31.8. Therefore, write mean formula 31.8 equal 2060 20x 40y divided by 100. Here sigma fi, this part sigma fi xi. Now simplify 318, 208, 2x, 4y. Now further simplify. Here divide by 2, x plus 2y, x plus 2y. Here 208. 110, 55. Second formula. Okay, now here 208, 313, 100, 110 or 255. Now it is okay. Now 2 minus 1, y equal 55 minus 34. 21. X value 13. 21, 13. 21 and 13. So we have deal with general formula. So two things unknown, but you follow general technique. Then try 2013, we have two questions. Try them. 56, 34. 22. 22, 12. 12. Correct it. Complete. Go to 2013, we have two questions. Start. Okay, 2013 question. The mean and mode of the following 8 observations, 4 and 6. 2, 3, 6, 2, 1, x, y, z. X, y, z real numbers. Calculate the standard deviation of 8 observations. Here mean for mod 6. Mod 6. Mean for mod 6. Now here we have for 6. Then x, y, z at least 1 6. 1 6 here. Sorry, 2 6. 2 6. Because here there are two values. Then mod is 6 now. Mod is 6. Therefore, mod 6 means x, y, z there are 3 values. Then definitely at least 2 will be 6. At least 2 will be 6. Then sometimes 3 can be 6. Now write mean. Then 4 x bar equal 4. 2 plus 3 plus 6 plus 2 plus 1 plus 6 plus 6 plus z over 8. 32, 10, 14, 26 plus z. Then z equals 6. Z equals 6. Therefore, x, y, z 6 plus 6, 6, 6. All are 6 values. No? Then standard deviation. Then variance, first find variance. 2 square, 3 square, 6 squared. Here 6, 1, 2, 3, 4. 2 square, 1 square. Over 8 minus x bar 4. 4 square. This is variance. Then square mean, here square mean minus mean squared. Mean squared. Now find the value. 4, 9, 36 into 4. 144 4 plus 1 over 8, 16 into 8. Simplify. 145, sorry, 154, 158, 162. 16. $64 over 4. Then standard deviation, square root 17 over 2. Square root 17 over 2. Here variance 17 over 4, standard deviation is square root. Okay. Then second question. So it's second question. A frequency table has 5 class intervals of equal width. Okay, here 5 class intervals. 1, 2, 3, 4, 5 class interval equal width. Frequencies. The upper boundary of, midpoint of the third class interval. 1, 2, 3, third class interval, midpoint 22.5. Mid value means xi value. The upper boundary of fifth class interval is 40. Here 40. Here 40. Then frequencies 7, 9, 19, 27, 15 and 2. Here are the values. Now, then here, now let class mid C, class with C. Okay. Now here 22.5 mid value. Then here this class upper boundary, here total C, no? Then 22.5 plus C over 2. Here 22.5 plus C over 2. Here upper boundary 22.5 plus C over 2. Then same value here 22.5 plus C over 2. Now we have to add another C. Add another C. Then 22.5 plus add C, 3C over 2. 3C over 2. Then you add another C here, then that equal to 40, no? Therefore, 22.5 plus C over 2 plus 2C equal to 40. Here 22.5 mid value, then class with C, then its upper boundary 22.5 plus C over 2. Then by that, then here class with C, then 22.5 plus C over 2 plus C, that will be upper boundary 40. Then find C value. Then multiply by 2, 45, 5C, 80, then C equals 7. No? C equals 7. Then class with 7. Calculate mode of the distribution. We have to calculate mode. Now here this is model class. Highest frequency class, model class. Then mode equal L1 plus C delta 1 over delta 1 plus delta 2. Then class with 7. Then you find class here, model class. Then 7, no? Then add 3.5, 26. Subtract 3.5, 22 minus 3, 19. Here this is model class. Class with 7, then 3.5, here 22.5, no? Add 3.5, subtract 3.5. Then you can find class with class, model class. 22.5, 25 plus 1, 26, minus 3.5, 19. Then mod equal L1, 19. C, class with 7, delta 1. Here frequency gap 8. Here frequency gap 12. Okay, na? Here 12. Now simplify, it is divisible by 4, 19, 14 or 5. 19, 14 or 5. 2.8, 21.8. Here this is the mod. That's the mod. That is 2013. Okay, 2012 part A question. 2012 part A question. Part A question. Okay, the mean and the standard deviation of 100 observations were calculated 30 and 4.1 respectively. It was later found that one observation has been erroneously recorded at 40 instead of correct value 30. Then that's wrong value. Then 100 observations, x1, x2, x3, x99. Then here wrong value 40 there. Then x bar equal 30, sigma I equal 1 to 99 xi plus 40 divided by 100. With 40 it is calculated. Therefore, sigma I equal 1 to 99 xi 30 times 100 minus 40. Then new mean sigma I equal 1 to 99 xi. Now you add correct value 30, divide by 100. Then here 30 times 100 minus 40 plus 30, divide by 100. Remove error value, then add proper value. Now here 2990, 29.9. Here this is new mean, 29.9, no? So 99 value is okay. Then here fake value. So we have added there for calculation. Then write original one. Then write proper values. Therefore, thereafter add that correct value 30. Here wrong, correct value 30. Okay. Then compute the correct mean and standard deviation of 100 observations. Then correct standard deviation. Now take that standard deviation formula. Then S squared equal sigma I equal 1 to 99 xi square plus here own value 40 square divided by 100. So here mean value given 30. Now S squared that is given 4.1, no? Then here 4.1 squared. Then sigma equal 1 to 99 xi square 4.1 square 30 square into 100 minus 40 square. Don't simplify. Yeah? At the final stage you simplify. For now don't simplify. Then new variance sigma equal 1 to 99 xi square. Now correct value 30. 100 minus x bar n square. Then here 4.1 square 30 square into 100 minus 40 square plus here sigma in 30 square divided by 100 minus 29.9 square. Now we have to find standard deviation. Compute the correct standard deviation. Then you take this value. Then standard deviation takes square root. Positive square root of that. Okay. Do the second question again. 2012 second question. 2012 second question. Okay, 2012 second question. 2012 second question. So the mean marks of school A and B test given their student 31, 45 respectively. Then here A, B mean 31, 45. The standard deviation of distribution of the mark A is 5. To compare the results of mark of school B are scaled by using linear transformation so that the mean and standard deviation of the school B same as those school A. Okay. The mean mark of school A and B test given their student 31, 45. Okay, mean mark given. The standard deviation of the distribution of the mark of school A is 5. That also given. Here standard deviation. To compare the result, the marks of school B are scaled by using linear transformation. So linear transformation means just like y equal mx plus c, like method of coding. Okay. Then I'll take yi equal xi minus a divided by c type. Here linear transformation. Say xi original. Then xi equals cyi plus a. Here xi original one. Here transformed value. Yi mean transformed value. So that the mean and standard deviation of school B, mean and standard deviation of school B, mean, standard deviation are the same as those school A, those of school A. Now here x bar equal, x bar B equal, here 31, S B equal, here 5. Okay. By transforming that convert into like school A. Now further, mark of 85. Here xi, let's say xn of 85. of school B becomes 63 under this transformation. Here under transformation, this become y1 63. Okay, this is original value 85 become original now transformed value 63. Find the linear transformation and hence find original standard deviation of the school B. Okay, then x1 become 63. Take this formula. This is original one. Original value 85. C yi here transform value 63 plus a. Here take first formula. Then according to this, x bar equals c y bar plus a. So now here mean transform mean 31. No, transform mean 31. Then transform in y bar 31. 31 c plus a. Now original mean 45. 45. It is given. Original mean given 45. Then after transformation, x bar equals c y bar plus a. Then here second formula. Here we get by these two. Now we have two simultaneous equation. Okay. Then 1 minus 2. 1 minus 2. Simplify. Then 85, 45, 40. A cancel. C. 63 minus 31, 32. 32. Then divisible by 8. C equal 5 or 4. Check simplification. 5 or 4. Okay. Then put that one here. Therefore, a value equal 85 minus 5 over 4 times 63. 5 over 4 times 63. Okay, simplify. Then you can get the value a. Therefore, here by this transformation, so here transform value SB transform value, then original value SB original C times SB, C times SB, then 5 over 4 SB value 5, 25 over 4, 25 over 4. Okay, no need to find a value. Here no need to find this. Okay, then let's move to last stage. 2016 part B question. 2016 part B question. Take that 2016 part B question that contain that proof. Okay, read it well. Okay, 2016 part B, mean and standard deviation of n numbers, mu1 and sigma 1. Okay, here x1, x2, x3, xn, here n number of elements, mean, standard deviation, here it is. Then y1, y2, y3, ym, here count m. Then mean mu2, standard deviation, here sigma 2 given, standard deviation. Now we have to combine this set. Combine set x1, x2, xn, y1, y2, yn. then total count m plus n. Total count m plus n. Okay. Then here mu1 sigma I equal 1 to n xi divided by n. Then by this sigma I equal 1 to n xi mu1 n, take 1. Then mu2 sigma I equal 1 to m yi divided by m. Then subject sigma I equal 1 to m yi mu2 m. Here is. Then here the mean equal sigma I equal 1 to n xi plus sigma I equal 1 to m yi divided by m1 plus m2. Then total sum divided by total count. Then x1 to xn sum, y1 to yn sum. We can do it separately. Then this is known now. Put there. Then mu1 n, mu2 m, m1 plus m2. Here the mean. By that formula we can do it. Let's complete that. This is mu3. Mu3. Mean of the combined set. Okay, then we need to calculate pool variance. This is pool mean. Then here this is pool mean. We have to calculate pool variance. Step is given here. D1 given. Here D1 given. Here pool mean. Pool variance proof. Then D1 given. Mu3 minus mu1. Now we have to find sigma I equal 1 to n xi minus mu3 square value. Check this one. Sigma I equal 1 to n mu3 value. Mu3 mean of this. Here this is mean. Here mean of this set mu3. Okay, mean. Then further you identify, simplify, we need to simplify this now. Sigma I equal 1 to n, here write xi minus mu1 plus plus mu1 minus mu3. You write this way first, then no issue. We don't have issue for this. See this one clearly. Yeah? So xi minus mu1, mu1 minus mu3. So I wrote that because here for this one, standard deviation, sigma I equal 1 to n xi minus mu1 square divided by n is this. That is standard deviation, no? Sorry, variance. That is variance. Check that. No? Here, sigma I equal 1 to n xi minus mu1 square over n is the variance. Then here standard deviation square. And by this, sigma I equal 1 to m yi minus mu2 square divided by m is standard deviation variance of this, no? Okay, clear this, huh? For this case, variance formula is this. For this case, variance formula is this. Variance formula. So variance mean you have to calculate mean and get deviation with that mean and square it. Here square mean xi minus mu1 square divided by n. This is original formula. Ne? Here x1, x2, x3 original data mu1, mu2, mu1 mean value. That is equal mean. Therefore, if you have x1 minus mu1 square, you can cross multiply this. Then you can write sigma I equal 1 to n xi minus mu I square equal n times sigma 1 square. Sigma 1 square. So that's why I took here xi minus mu1. Xi minus mu1. Then here xi minus mu3, you write xi minus mu1 plus mu1 minus mu3. Again we have given here mu3 minus mu1 value. Mu3 minus mu1 value. Now you expand this. Just expand this square. Sigma I equal 1 to n xi minus mu1 squared plus 2 times xi minus mu1 minus mu3 plus mu1 minus mu3 square. Now separate sigma. Sigma I equal 1 to n xi minus mu1 squared plus sigma. Here we can take 2 mu1 minus mu3 outside. They are constant. No? Mu1 minus mu3 take outside. Sigma I equal 1 to n xi minus mu1 plus sigma I equal 1 to n mu1 minus mu3 square. First do up to this. Do up to this. You practice this proof. Huh? Do up to this. Okay. Then here I equal 1 to n xi minus mu1 square equal n times sigma 1 square. Here instead of this you write n1 times sigma 1 square. Here 2 mu1 minus mu3 into here sigma xi, no? Sigma xi, sigma mu1. Sigma xi, sigma mu1. See what is that? Here sigma xi. Here sigma xi equal mu1 n. Sigma xi equal mu1 n. Here mu1 n. Here sigma mu I mean mu1 n again. Okay. So that part 0 now. Then mu1 minus mu3, that is given mu3 minus mu1 d. Then it's square d1 square sigma 1 to n mean we have to multiply by n. No? We have n count. This is constant. Sigma k equal kn. 1 to n sigma k equal kn. Here mu1 minus mu3 square mean d1 square. Here d1 square that has n times. d1 square times n. Here for this part 0, then final result is this. Then you can take final result. I'll write here. Here n1 take outside. This is d1 n1. Sorry, n. Here this is n. n sigma 1 square d1 square. Here the result. Okay, first do up to that. Okay. Now see pool mean. Here this is the pool now. Mu3 minus x1 or x1 minus mu3 square, x2 minus mu3 square, x3 minus mu3 square, it goes so on. Xn minus mu3 square, then y1 minus mu3 square, y2 minus mu3 square, yn minus mu3 square. Okay. Then here sigma 3 square, see this one, x1 minus mu3 square, x2 minus mu3 square, it goes on up to xn minus mu3 square, then go with y. y1 minus mu 3 square, y2 minus mu 3 square, it goes up to ym mu 3 square divided by m plus n. This is pool mean, pool variance. Okay, that is pool variance formula. x1 minus mu 3 square, x2 minus mu 3 square, it goes up to xn. Then y1 minus mu 3 square, y2 minus mu 3 square, that goes to ym. Then we can compress this. Here this part we can compress. Then that equal to sigma I equal 1 to n xi minus mu 3 square plus here sigma I equal 1 to m yi minus mu 3 square divided by m plus n. So here the pool variance. Now instead of this, we prove one thing. So that is n times sigma 1 square d1 square. Then you write here n times d1 square. And for this you similarly write m times d2 square. Similarly write that one over m plus 1, m plus n. That is pool mean, pool variance of the distribution. Pool variance. Okay, complete it. That's the proof. Huh? So now here proof somewhat hard, but question is simple. So we have to apply that one. The number of copies sold per day during first 100 days after publishing new book. First 100 day. Mean 2.3, say here mu1, and variance 0.8. Next 100 date, m 100, mean mu2 1.7, variance 0.5. Find the mean and variance of the number of copies first 2020 days. Question එක error එකක් තියෙන්නේ. මම දීලා තියෙන එකේ error එකක් තියෙනවා. 100 first 100 second 120 කියලා ගමු අපි. First 120 here. First 100 days, second 120. Take that one. So 120. Okay, now let's do. Then mu3, 100 times 2.3, 120 times 1.7, divide by 100 plus 120. Then you can find this value. Then mu3 square 1 over m1 plus m2 mn n times m times sigma 1 square d1 square plus m times 2 square. Then we know mn 1 over 100 plus 120, here 100, 0.8, 120, 0.5, here d1 square, d2 square. So you find this value, then d1 mu3 minus mu1, mu3 minus 2.3, d2 mu3 minus mu2, then mu3 1.7. Then finally you substitute the values here. That is pool variance. This is pool variance. You have to calculate one decimal place. Okay, 2014 part B question. 2014 part B. Here we have to think and do. We have to think and do. 2014 part B. Now first on general proof. First on general proof. 2014 part B question. Here data set x1, x2, x3, xn. Here x bar mean sigma I equal 1 to n xi divided by n. Then sigma x square mean sigma I equal 1 to n xi minus x bar square divided by n. Okay, this is general one. Here expand sigma I equal 1 to n xi square 2 x bar xi plus x bar square divided by n. Identify xi is the variable, x bar is the constant. Now separate sigma. Sigma I equal 1 to n xi square divided by n 2x bar into sigma I equal 1 to n xi divided by n plus sigma I equal 1 to n x bar square divided by n. This is it. Okay. Then here write x sigma x square I equal 1 to n xi square divided by n. Here this is 2x bar. Again this one we call x bar. Then plus here x bar square 1 to n sum. That means n x bar squared divided by n. Here this is equal n x bar squared divided by n. Then sigma equal 1 to n xi square divided by n. This proof we have done. Minus x bar squared. That is it. Let alpha beta real constant. Now here we have to prove sigma I equal 1 to n. Second part. Okay. Alpha xi plus beta squared. So expand inner bracket I equal 1 to n. Here alpha square xi square 2 alpha beta xi plus beta squared. Now separate sigma. Sigma I equal 1 to n. Take alpha square outside, constant. Then xi square plus 2 alpha beta xi. Before that sigma plus sigma I equal 1 to n beta squared. Now here sigma xi square subject by this sigma xi square I equal 1 to n xi square equal times n. Here it is. Put this one here. You can put here alpha squared. Here sigma x squared x bar square times n 2 alpha beta sigma xi. Here sigma xi equal nx bar plus here beta sigma I equal 1 to n beta square mean beta squared n. Beta squared n. Now it is done. No? Then here n alpha square sigma x squared there. Then the other part alpha squared. Take the other 3 together. Now you take the other 3 together. Here. So that equal to n alpha square sigma x squared plus n alpha square x bar square plus 2 alpha x bar alpha beta x bar plus beta square. Now n alpha square sigma x squared n alpha x bar plus beta squared. Here it is. Okay. Complete up to that. This is not statistic. Huh? This is sigma notations. Sigma simplification. Further we have to prove here yi alpha xi plus beta, then sigma I equal 1 to n yi, sigma I equal 1 to n alpha xi plus beta, divide by n. This is equal y bar. Separate sigma xi I equal 1 to n divide by n, sigma I equal 1 to n beta divide by n. This is equal x bar. Then y bar equal x alpha x bar. Here beta sum, then beta times n divide by n. Then alpha x bar plus beta. Alpha x bar plus beta. That thing also we have done before. Here linear transformation, then alpha original mean or original value. Then here original mean we have converted into linear transformation. Then by using 1 and 2 deduce sigma y squared equal alpha squared sigma x squared. You have to follow that. Then here sigma x square 1 over n xi square I equal 1 to n minus x bar squared. Therefore, sigma y square 1 over n I equal 1 to n yi minus y bar square. Then 1 over n yi I equal 1 to n yi mean alpha xi plus beta. Then y bar mean we don't have sigma here. Y bar mean alpha x bar plus beta square. Alpha x bar plus beta square. Then we have to convert that. Then here this thing we have done before. So that is, here it is n alpha squared sigma x square n alpha x bar plus beta. Na? Beta. Put that one there. Okay. Then 1 over n. For this one write n alpha square plus n beta alpha x bar plus beta square. Now simplify, cancel n, cancel these two, then we have Here it is. That's the proof. Then that proves somewhat hard, but question simple. Proof somewhat hard. Now let's see. The mean of marks obtained by candidate in a certain examination is 45. Here x bar is 45. These marks are to be scaled linearly to give mean 50 and standard deviation. Then take transformation yi alpha xi plus beta. Then corresponding mean y bar equal alpha x bar plus beta. Then corresponding variance sigma y squared equal alpha square sigma x squared. No, that is transformation. That is linear transformation. So here original marks, we have to take that into 45. Mean 50. Standard deviation 15. 15. Is it so? The mean marks obtained 45, that is original one. These marks are to be scaled linearly. You mean 50. Then converted one 50 and standard deviation 15 and converted standard deviation 15. It is given that the scale mark 68. It is given that scale mark 68 corresponds to the original mark 60. Then here xi original mark 60 has scale yi. Yeah, say 1 68. No, scale mark 68, original mark 60. Calculate standard deviation of the original mark. So take here yi 68, here 68, alpha times xi 60 plus beta, say 1. Then here y bar 50, alpha times x bar 45 plus beta. Then solve simultaneous equation. 1 minus 2, 18, 15 alpha. Then divisible by 3, no? 6 divided by 5, alpha value. Then put it here. Beta value 68 minus 6 over 5 times 60. Seven 2 here minus 4. Beta value minus 4. Okay. Alpha value 6 over 5, beta value minus 4. Now we have to find new variance. So you take this formula, scale variance, alpha means 6 over 5. So here 15, no? Sigma x squared. Here transform variance, transform standard deviation 15, no? Then 15 square, 6 square, 5 square, sigma x squared. Then 15, 6 over 5. Here this is standard deviation of original one. .5. Here 12.5 is standard deviation. Carefully read. Huh? Calculate standard deviation of original mark. Here original mark, standard deviation. It is given further that the original mark m obtained by candidate is not lowered by the above scaling. is given further that the original mark M obtained. Finally, it says that there's original mark M. There's original mark M. Here, the linear scale yi equal xi m alpha xi plus beta. No? Then original mark M. Alpha mean 6 over 5. M. Beta mean 4, minus 4. Here yi. Not lower. Then our actual value M. Then here scale mark not lower than M. Therefore, this value must be greater than or equal M. So here transform linear as per transformation, we got this one. So that not lower than the original one. Then here original one. Now simplify. 6m minus 20, 5m, then m 20. That is it. Okay, then that's all about statistic. That's all about statistic. We have done everything, all proof we have done. Nah? You practice remaining question and repeat these questions again and again. These last things are somewhat hard, but generally available question will be very simple. Nah? Okay, that's all about statistic.